Hey guys, welcome back everybody. So today we are going to discuss about how to configure the static route. So this is our topology. So before I'm going to start the lecture, right? So what I can do that, let me tell you, there is a three ways to configure the static route. So one base is what you can put the command IP route. Then you need to put the destination network, right? And then you need to put the subnet mask information. And then you need to put the next hop. So this is the one way that you can configure the static route. Second base we have IP route, destination network. Then we have a subnet mask information and the exit interface, right? So this is the second ways that you can configure the static route. The third ways we have, let me copy and paste exit interface plus next hop. So in this video, what we are going to discuss, we are going to discuss about how to configure the static route in the first way, right? And then we'll see the problem with the first case, right? Then we'll jump to the exit interface and the exit plus next hop information, right? So this is the topology that we are going to cover it. So you can see that we have a different sites we have. Take example, we have in the Delhi, another side in the Patna, and another side in the Bangalore location, right? So three different sites we have. And as we know that static routing is a totally a manual configuration, right? It's not a dynamic way. So a network engineer has to go on every box and need to do the configuration of the route. So a network engineer has to go on this box, on this box, and this box, and they need to define the route for that particular network, right? So you can see that I already mentioned the IP addresses over here. You can see that I have a 1.100 for this particular interface. Then this subnet, we are going to use 10.1.12.0/24, 12.1 for this particular interface, 12.2 for this particular interface. Same way for this particular LAN network, we have a 2.0 subnet, 2.100 this interface, and the 2.1 for this IP address, this PC. So this 2.100 will become the default gateway for this PC. Same way you can see that we have a 1.0/24 for this LAN network. This is the 1.1 IP address for this PC. This IP will become the default gateway for this PC again. Same way if you can see the 23.2 on this particular interface and 23.0/24. 23.3 on this particular interface, and we have a 3.100, right? This particular interface. Same way we have a LAN information 3.0/24 and 3.1, the PC3 IP address. Same way, this IP address will become the default gateway on this PC, right? So I haven't configured anything, right? Not even the IP address on the PC side. So let's start the configuration, right? So on the PC side, what I can do that, I'll just go on the PC desktop and the IP configuration. I'll just put the IP is 192.168.1.1/24, and the default gateway is 1.100, right? Same way on the this router, on the router interface, if you go to the 0/0, right? Say the no and enable. Let me change the host name first of all. Host name is router number one. I say the interface 0/0, and I can call this guys a 192.168.1.100/24. And then we have a interface 0/1. That's we have a 10.1.12.1/24, right? That's all done. So by default, all the layer 3 interfaces are down. So you need to up that particular interface by using the no shutdown command. And the same way, I just need to go on the router number 2. On the router number 2, we need to first define the IP addressing, right? So the no, enable, config terminal, host name will be router number 2. Interface 0/0, I can say the 10.1.12.2/24. And then we say the no shutdown. Then we have another interface. We have a interface 1/0, 10.1.23.2/24, and no shutdown. Then another interface we have that's facing to the LAN side. This particular interface 0/1. It should be have a 2.100, right? And here we go. So all done now on the router 2 as well. Let me do the configuration for the PC2. On the PC2, we just need to go on the desktop IP configuration. And here we have a 192.162.1, and the default gateway will be 2.100. So this is the configuration for the PC number 2. Same way on the router 3, we need to do the configuration. On the router 3, we have a no, right? Enable, config terminal, host name will be router 3, interface 0/0, IP address will be what? It should be the 10.1.23.3, right? And no shutdown, which is this particular interface, 0/0. On the 0/1, we have 3.100, 0/1. I need the 191.63.100. That's a class C IP address, and all done. So same way, we need to configure the PC3 as the IP addressing and the default gateway as well. So 191.63.1, that's the IP address of the PC. Oh, I'm so sorry. 192.168.3.1. Come on. And the 3.100 will be the default gateway. So that's done of the IP configuration on every device. Switches, we don't need to configure anything. I took the switches just to help the connectivity between the PC to the router, right? Okay, you may have a question, hey, Log, can we do like this, babe? Can I connect the PC directly to the router? You can do that, okay. So, but right now I'm just making us very simple topology, right? So that's why I took the help of switch. Now what, if you check the router right now, the router number 1, right? What you can find, I have a routing table, so IP route, but in my routing table, I only know about my directly connected router. C means what? It's a directly connected. So I only know about my own information, right? Even if you go on the router number 2, on the router number 2, if you verify the so IP route, I have a only own information, that's a 12.0, 23.0, the subnet, and the LAN network 2.0. Same way, if you check on the router 3, on the router 3 also we have a routing table of my directly connected 1.10, 10 or 1.23.0, that's my this interface route, and the 3.0, the LAN network. So from this PC, right, if I'm on a PC1 and I can ping my default gateway. If I'm going to send the traffic to my default gateway, I can easily send the traffic. I can easily send the packet to the default gateway, right? Because I have defined the default gateway information on the PC side. But I cannot send the traffic. You can see that I'm able to send the traffic, right? I'm getting the reply from the 100. The size of the packet is a 32 bytes, right? The TTL that I have defined the 255 over there. That's a default behavior on the PC side. Now I'm getting the reply from the gateway. So I do have a communication from here to here, right? But I don't have a communication from Delhi to Patna. I don't have a communication from Delhi to the Bangalore. The reason is that we don't have a routing. Routing in the sense of what? For example, if I'm on a PC1 and if I say that, hey, I like to send the traffic to the Patna, right? So we are in the Delhi right now. So I said that I want to send the traffic to the 192.168.2.1, which is in the Patna right now, this guy. So the source IP will be what? The 192.168.1.1 will be the source IP. The destination will be what? 192.168.2.1 will be destination IP address, right? So understand this concept. So here I'm not going to talk about like whatever the layer 2 MAC address and ARP concept right now. So we already made the ARP videos, right? So what happened? The PC will send the packet to whom? Default gateway. Based on the AND operation, right? They have decided I need to, this IP is in the different broadcast domain. So I need to forward the packet to the default gateway. So when the router 1 will receive the packet, what router 1 will do that, right? Similar to the phone. So if you're going to make a call to someone, right? If you have a number of some guy, then you can make a call, right? If you don't have a number in your phone, you cannot make a call. Same thing, when the router will receive the packet, what router will do that? Router will perform the lookup in the routing table. Hey, do I know about the 2.1? So if the router 1, right, receive the packet, say, hey, do I know about the 2.1? According to my routing table, I have no idea about the 2.1. So when the router receives the packet, what router will do? It will perform the destination lookup. It will perform the destination lookup. It will perform the lookup for the 2.1. So do I know about the 2.1? No, I don't know about the 2.1. So what simply router will do? It will drop the packet. Because I don't have a route. So to avoid this problem, right, we came with the picture, right, called as the routing. So routing has a defined in the two ways. We can call as a static routing, and another way we have a dynamic routing. So today, as I mentioned that, right, we are going to talk about the static routing in the first ways, that we have three ways to define the static route. One is IP to destination network subnet mask and next hop information, right? So the first ways we are going to use to define the static route. So I'll give you the small trick, right? In a static router, what? So in a static routing, you have to define only those network which is not present in your routing table. According to this topology, try to understand. According to this topology, I already have a network, right, of the 12. I already have a network of the 1 or 0. I don't have a network of what? In my routing table of R1, I don't have a network of this guy. I don't have a network of the 2.0 as well, right? I don't have a network of 2.0. I don't have a network of 3.0 as well. So on the router 1, I do not have this one, and this one. So all these three networks you need to define on the router 1. So in the static routing, what happened? The network which is not present in your routing table, you need to manually bring those out. But in the case of dynamic routing, you only need to advertise the directly connected route. Okay. So that's a basic difference. So in a dynamic routing, you're only going to advertise the directly connected route, which is present in your routing table. But in the static routing, what happened? Whichever the route which is not present in your routing table, you need to bring this route manually, because the static route is a manual way. So what I can do that the first command I'm going to apply on the router 1, because I don't have which route. I don't have a red color one. So let me, okay, 1 minute. I don't have this information. I don't have this information. So I just need to go on the router 1. The first keyword I will mention that over there, IP. The IP keyword, it's going to represent you, hey, you are doing the configuration for the IPv4, right? Then the next other keyword we have is saying the route. Route means what? I want to go. I want to go to this particular network, 10.1.3.0. That's my destination network. What is the subnet mask for this destination network? /24. And if I'm going to send any traffic to this guy to whom I send the packet, so my gateway for this particular person, right? For this particular person, if you're sitting over here, try to understand. If you're sitting over here and if you want to go to this particular subnet, right, which will be the gateway for you. So this IP, right, will become the gateway for me. That's called as a next hop. So next hop always will be your what? Always will be your neighbor IP address. Your next hop always will be your neighbor IP address. In some scenario, the next hop will be changed. It could not be a neighbor IP address. It could be this IP address as well as, right? That we'll see that I'll make a separate video for those things. But understand this concept. The basic part is what? So next hop always will be your neighbor IP address. So when I'm going to send the packet to this particular network, right? My next hop will be 12.2. And your next hop will be changed depend on the flow. Flow means what? Take example. So if you're sitting on the router number 2, right? And if you want to go to this particular subnet 1.0/24, 1.0/24. So if you go to this direction, the next hop will be what? 12.1. Same way, if you want to go to this direction, right, 3.0, what will be the next hop? 23.3. So next hop will be changed depend on the flow. So now let's define the next hop is what? I say that 10.1.12.2. Same way, I do not have a route for this guy 2.0/24, and same next hop, and same for this guy as well, right? So now you can see that do show IP route. I have it out in my routing table. So for the static route, what happened? We don't have a metric concept. This 0 is going to represent the metric. Static route doesn't have a metric, but a static route has a AD value is a 1. AD is known as the administrative distance, or sometimes it's called as a preference value as well. It's a 8-bit of number. That's 0 to 255. 0 is reserved for the connected route, right? And 1 is reserved for the static route. Same way, the OSPF has a 110, EAGRP has a 90 and 170, BGP has a 20, 200 and 200, right? Different routing protocol has a different AD values, right? AD is just gonna tell you the trustworthiness of the route. Lower AD is more preferred. So take example, if the router 1 is getting the one route with the 1.0.0.0.0 with the AD1, another route 1.0.0.0.0 with the AD number 2. So router 1 always give the preference to the lower AD, right? This AD is this AD will be changed depend on the platform. So if you go to the Juniper side and HP side, right, Aruba Networks and Arista, right, AD will be different. Even the Palo has a AD different. So make sure that we are talking about the Cisco perspective. So AD is the one according to the Cisco perspective. So now the same way, you can see that on the router number two, I don't have which information. On the router number two, I do not have a this guy and this guy, 3.0, right? So this two network I'm gonna define on the router number two. So on the router number two, I need to say that, hey, listen, IP root 191.61.0/24, and the next W what? 10.1.12.1. So if I'm gonna go this direction, right? So my next W what? My neighbor IP is 12.1. And if I'm gonna this direction, my next W what? 23.3. Same way IP root 3.0, and here we go 10.1.23.3. Now if you verify the do show IP root, I have a route in my routing table. If you go to the router 3 now on the router 3, if you check, I do not have a which route. On the router 3, I don't have a information about 12 and 2.0 and also the, sorry, 1.0 and 2.0. So I'm sitting on the router 3 right now. On the router 3, I don't have this information. So on a router 3, I just need to go and say the IP root, right? And I say the 10.1.12.0. As I mentioned that static route is a manual way. So you need to go each and every box and need to define the static routing. So you need to do the box to box configuration. So here we go to next W what 10 or 123.2, because if you want to go to this direction, right? My next W what 23.2, always my neighbor IP address. So for the router 3, the neighbor IP address will be what 23.2, not the 12.2. 12.2 is a different broadcast domain. Even the 2.100 is a different broadcast domain. So my neighbor IP address is a 23.2 in the same broadcast domain, right? So let's done. IP root 10.1 dot not 10.1.192.160.1.0/24, and I'll make sure this guy's a 23.2, and IP root as well 2.0/24 and 10.1.23.2, and done. So that's how you can configure this static route, guys. Again, I'll make a new videos for this one, like what happened if I'm going to define the next stop 12.1. So mostly what happened when the people are doing the CCNA, right? So they do the mistake, right? So instead of defining the next stop, for example, if you define the path for this guy 1.0, so what most people are, do this thing, they define the next stop is a 12.1 instead of the 23.2. So yeah, again, we can define the 12.1, but they have a different behavior. Okay. So the best practice is what? Define the neighbor IP address as a next stop. You can also define the 12.1. I'll make a new video for this one, and I'll show you the problem of that case. Okay. Now, so if you see, I have defined the static route. So on the router 3, you can see that. Let me copy and paste. I'll show you the show running config, and I'll copy and paste on the notepad so that in the last you can, if you want, you can copy this configuration. So that's for the router 3. And how the router 2 right now? I have a router 2 as well. Do show run. Copy. And here we go. That's my router 2. And that's another one is a router 1. So that's the static route that I define on the all the router 3, router 2, and router 1. The first way to define the static route, this one. Right now, if I'm going to send the traffic, understand this concept. First, I'll show you the ping is working right now. So if I'm going to ping the 2.1, right? So I say the ping 2.1, right? So from here to here, I'm sending the traffic right now, right? So 1.1 will be the source IP address, right? So if you see the packet structure right now, so source IP will be 1.1, destination IP will be 2.1, because I'm pinging to the 2.1. So my ping is 1 over. They are doing the ARP operation, right? So that's why your request timeout the first one. Now I'm getting the reply. Same way, let's send the traffic from the PC1 to the PC3. Can also send the traffic. I see the ping 3.1, right? So this the PC3 is a 3.1. So I can send the traffic from Delhi to the Bangalore as well. All good. So I have a proper reply, right? So I do have all connectivity. Now understand the flow. So normally in this case, what happened? Not the full detail, but I'll give you the understanding of the static route of the next hop concept, right? So when I'm sending the packet to the PC1, right? When the PC1 is gonna send the packet to the switch, right? They will do the MAC address lookup and they will send the packet to the router one. So when the router one will receive the packet, right? Forget the layer 2 perspective, the MAC and those things. So when the router one will receive the packet, what router will do that? Router one is gonna perform the destination lookup. By default, right? By default, router does the destination lookup, and that's why it's called as a destination based routing. That's why it's called as a destination based routing. It doesn't mean that we don't have a source lookup and we don't have a source based routing. We have a source based routing too. That's called as a policy based routing, the PBR, where the router will do the source lookup. But the default behavior of the router is what? Whenever the router receives the packet, they do the destination lookup. So it will look up the destination part in the routing table. Hey, do I know about the 2.1? So let's go to the router one. And if you go to the router one and see the so IP route, right? According to my routing table, right? According to my routing table, he said, hey, I know about the 2.0 right now /24. And according to my routing table, right? According to my routing table, I need to forward the packet to whom? 12.2. Okay, that's fine. So router one has a routes about the 2.0 subnet. And according to the routing table, he said that I need to forward the packet to the 12.2 to this guy. So I need to forward the packet to the 12.2. So can you see that what's happening over there? I have a lookup for this guy, 2.0 subnet. That's I have. I need to forward the packet to the 12.2. What's the bridge over there? So how do I send the traffic to the 12.2 now? He mentioned that according to the routing table, I need to forward the packet to the 12.2, but how? From which interface? Because take example, a router 0/0 we have, 0/1 we have. Interface is what? Interface is like a gate. A room has a multiple door, right? A room has a multiple doors. So same like that. On which interface I need to forward the packet? 0/0 should I forward the packet? Okay, you told me that you need to forward the packet to the 10.1.12.2 according to the routing table. But from which interface? 0/0 or 0/1 or 0/3? So you haven't mentioned the interface over there. So in that way, what happened? The first lookup, right? To understand this concept, the first lookup that I did for the destination part, the first lookup, right, that router does is for the destination lookup. Second lookup that I'm gonna do that what? Because you told me I need to forward the packet to the 12.2, but where is the 12.2 is connected? So second lookup, I will look for the exit interface. So it means that whenever the router will receive the packet, whenever the router will receive the packet in the static routing this way, in this static routing, what happened? The router has to perform the 2 times of lookup. If they are receiving the one packet, they need to perform the 2 times of lookup. So one lookup is gonna do for the destination guys, and second lookup he's gonna find the from which interface I'm going to send the packet. So exit interface, it will go, okay, I need to forward the packet to the 2L.2. The 2L.2, right, is connected with the which interface? 0/1. So the first lookup I did for this guy. Second lookup I need for look for the where is the 2L.2? The 2L.2 is present over the this interface 0/1. This mechanism is called as a recursive lookup. This mechanism is called as a recursive lookup. And in this case, what happened? Your CPU will be a very high. So every time a data will receive the packet, right? They need to perform the two times of lookup. First lookup for the destination and second lookup for the exit interface. And that's how the recursive lookup comes in the picture. And sometimes, right, this kind of static routing is also known as a recursive static route. So sometimes in the interview, the people ask the question, hey, what is the recursive static route? So recursive static route is simple way, right? Whenever the router performs the two times of lookup, more than one times of lookup, simply, right? It's known as a recursive lookup. And it is known as a recursive static route as well when you define the route with the next hop, when you haven't mentioned the exit interface. So that's a problem of this static route. And that's why we have different ways, right? Like exit interface plus next hop. Okay, so we'll make a separate video for this one, right? This two one as well. So I hope you enjoy this session, and I'll see you in the next session. Thank you, guys.